Hello everybody, my name is Mitchell Henry. I'm an application engineer over here at Concepts in Production. Today I'm going to show you all a short presentation on how to utilize top-down assembly modeling techniques to speed up and improve your SOLIDWORKS modeling skills. So here, let's start out with a simple assembly ready for us. So here we've got like an oil pan component and then a pipe. This would go off. But we need to first off mate this component up, then we're going to transfer these holes over, and we're also going to make a little gasket because we don't trust the machining of this surface and that surface, so we want to just put a little gasket in there. So first thing we're going to do is we're just going to grab the circles and do our general basic mating. I'm going to grab this cylinder and this cylinder, and if you've never noticed, there's quick mates right at your fingertips of the mouse. If you don't click on anything else after just clicking on the things, that really speeds things up. Here again, this cylindrical face and this cylindrical face, it'll pop up this menu just at our mouse rather than having to go in and use the mate tool. This is usually a little bit quicker. I'll click these two surfaces. We could do something like a coincident mate or parallel, but in this case we need distance, and it even allows you to put in a particular value. Here we're going to put in a 50 thousandths gap between these two components, and that's the crushed gap of our copper gasket that we're going to be using. Now we've got our pipe put together. We're going to take our normal assembly button here of the insert component. We're going to do the drop down to select a new part, and this is going to create a new part in the assembly. I'll do that initially, and it's going to ask me, if you'll notice my mouse has a little check mark next to it, it's asking me what sketch plane I want to initially start working on. Just like when you would first create a sketch in a new part file, it's going to try to ask you which of the primary planes you want to start sketching on. It's doing that to try to help orientate what those initial planes should be. So here I'm going to say that I want to grab that surface. You'll notice if I expand the part, there's not currently any geometry in the part. It's literally just a blank file for the part, and we're going to have to add in the geometry. You'll see I clicked on that one face, so here's our origin for our sketch, and you'll notice from the orientation of the X and the Y of it, it's about flat with our screen right now, and now it's about normal to our screen, and it's actually on that edge. So what I'm going to do with that, I'm going to use our convert entities on this other component, and it's going to grab features from that component. And if you're not familiar with the convert entities, it grabs things like lines and circles from other components into a sketch. So there it grabbed the entire exterior surface. Then we also need to do another convert entities of our interior circle there. You can see in black that we've got all the sketch geometry that we need. So now you'll notice up here we don't have the traditional assembly tabs, we have the actual part file tab. So we have our features, and you'll notice that consistently whichever tab we're on, we always keep this one, and that allows us, if we don't want to have any actual dynamic references, we can break those, or we can make the entire assembly transparent, or just exit the editing of this part in context of the assembly. But I'm going to click over to the Features tab and do an extruded boss from our sketch, and here I'm going to reference it to our part by doing an up to surface and saying that it needs to go up to that gasket surface, and that'll create it at whatever thickness we want it to be. I could go in and change what our distance mate is to make it thinner or thicker respectively. I'm going to do one more thing of right clicking on our material and turning it into a copper. So now we can hit OK, and you see that we just easily and quickly made that little copper gasket because we were able to reference it off of the other parts that it's made it up to. So the other part that we have is that we have these holes, and particularly these holes were created with a hole wizard feature, and that's going to be very useful for us because we're going to be able to transfer the data of that hole feature and propagate it through our parts. And how we're going to do that is we're going to use some of the assembly features, and we're going to grab the whole series. And you'll see here, it looks like the normal sketch tool, or the hole wizard tool, where we're going to place a hole and then we tab over and set up our holes just like you normally would with the hole wizard. But instead, I'm going to click on the use existing holes. I'm going to click on one of these surfaces for it to grab the original hole wizard feature. And you'll notice with the yellow preview here that it's actually propagating that hole through the next few parts. And if we didn't want it to go through the next few parts, we could click in here to the steps that it's cutting through and set up, like maybe it only needs to go in a certain depth or so. We could set that up appropriately here. Or you'll notice that the initial hole condition it recognizes from having clicked on the hole wizard. But our last tab here is very useful to us. It allows us to put fasteners on. Like, it'll actually create what we call smart fasteners, and this is your bolts and your nuts and your washers. So I'll click that I do want to place the fasteners, and you'll see that our preview is trying to come in at an odd angle. You can ignore that for the time being because it will come through correctly, but you see that it's trying to put in a countersunk Phillips head screw, and right now it's just long enough to go through the length and have a little bit of stub sticking out. We're going to add on to the stack of the fastener, and we're going to put a regular washer on, and you'll see it'll try to preview it. Once again, the preview comes in a little wonky. Then we'll also add an additional item of the hex nut, and that also adds to the stack. And if you notice, the bolt was getting longer as we added items to the stack. It'll make sure that the shank length of the bolt is long enough to incorporate all the components that you're putting on. So now that we like what our hardware setup is, I'm going to hit OK, and our holes have been propagated through the two components, even the component that we just created. The washer has been added, the bolt has been added, and the hex nut has been added. I'll click on this component, copper crush gasket, and I'll open the part. Now here, if I wanted to, we could save as and save it out. Let's say that needs to be called copper gasket. I'll put it here, save it, and I'll close and switch back over. And now you'll notice in the assembly it's properly referred to as the copper gasket. So there you can easily and quickly create your components for your assemblies in the context of the assemblies, and that's pretty useful. Like if you have various features like this particular profile of this mating surface, you can propagate that onto your part. So that's everything that I've got with this example. So let's move on to one of our other examples. So here, now we're going to open up our Weldments structure. Now this is a structure that we created in the Weldments webinar about a month ago. I've modified this now so that it's got some feet on it, and we're going to put some casters on it. Say that this needs to be a little work table that needs to move around the shop. You've already designed the weldment structure of it. Now you need to be able to put the caster wheels on it. We're going to put on a component because if you'll notice, the bolt pattern here is not going to work with the end of our tube. We're going to need to put some sort of plate there and incorporate the design so that the caster bolt pattern can bolt up onto our table. So what we're going to do is we're going to once again insert a new part. I'm going to say that the part needs to be on that surface. Then I'm going to create a square. Now I also need to locate that square to be in the middle of the tube. So I'm going to grab two opposite edges, put them on midpoints, and now that construction line that I just created, I'm going to put the point that's the middle of our square at the midpoint of that. So here I'm also going to say that these two edges are equal to each other so that we have a perfect square, and that the plate needs to be a 5x5 plate. So there we've created what the plate needs to be. Now I'm going to tab over to the features, do our extrude down. Here we're going to put in that the plate needs to be a 1/4 inch thick. We're good with that. Now here you could have the plate is there, but it's still not attached. You could maybe have a welder weld this edge But instead I'm going to have an additional tube that's slightly larger than this tube that's welded just to this plate so that it'll slip on and off. That way you can quickly and easily remove the feet if need be. So here we're going to do that additional change. I'm going to put a new sketch. I'm going to do a convert entities, and this time, give me a second, I'm just going to hide it. So we're still sketching on that plane even though the solid body of the plate is hidden. I'm going to convert the entities of that edge, and it's going to grab all the exterior edges just like last time. And you'll see with the black lines that we just grabbed all the exterior edges. Then I'm also going to do an offset entities of that line set with our proper thickness. Now here I will unhide that body, and with our sketch that we just created, we'll extrude it up to make our tube. Let's say that it's 3 inches of tube. So there, that looks pretty good. These two, this square tube and this plate, we're going to have welded together. So I'm going to put in a little fillet just to denote that it's welded. But we still have the problem that there's not the bolt holes. So just like with our last part, we're going to mate this, and then we're going to transfer those holes and create all the fasteners for it with the hole series component. So we finished this component, so I'm going to click that I'm done editing. Here I'll show y'all my favorite type of mate in SolidWorks. I clicked on this surface and this face, and this last option here is profile center, and that'll grab the center of any regular profile and line it up so that it's fixed to it. So it's both the two faces that are flat are always going to be coincident with each other, planarly stuck together, and it's going to line them up and center them. So this is really useful like if you have an oval and a square, or a square and a rectangle. It's always going to line up the exact middles of them and put them flat with each other. And you'll notice that down in the corner here, that's fully defined. So that one mate mated this entire caster part, which was completely undefined in space, perfectly to this plate. So that's a pretty powerful little mate tool right there. But like I said, we now have to transfer the hole series through. So here we'll grab a hole series. We will once again recognize pre-existing holes. It'll propagate the hole through. I will click over to our final tab and place fastener. And here, this time, it recognized that it wants to use a Allen head, or in this case, it's referring to it as a socket cap screw. Say I wanted to change that, I could just right-click on this and change fastener type. So here we got a lot of different options, like a hex head, or maybe a machine screw, or in the previous case, we used a countersunk head. I'm okay with these socket heads though, so I'm just going to hit OK that I'm okay with that. Then, just like last time, we're going to add things to the stack. Just to demonstrate it, I'm going to add a washer on the close side of the screw. Then you'll see that'll be added to the stack, as well as I'm going to add a washer and a nut to the far side of the stack as well. So there's one washer, and then a hex nut. And once again, you'll notice that the shank length of the bolt is growing, so that it always has an appropriate amount of extra thread sticking out. And it's recognizing the bolt type from the hole. So I'll hit OK, everything looks good there. It'll take a second to think and place all that. But here we transferred the holes onto the other components, and we created a bunch of hardware for us that's fully defined into our assembly. So here we did it for just one corner, and instead of redoing the work on each of the different corners, we're going to use a pattern, which is just like a sketch pattern or a feature pattern on your part level. There's also these assembly level patterns. So we're going to go up here under our assembly tab, we're going to grab the linear component patterns. I'm going to grab the components that I want to use, which is going to be all the components in this little corner, and I'm going to define my directions, and I'm going to do that by grabbing edges. So here the directionality of it is wrong, so I'm going to flip that direction, and our distance is off, so I'm going to put in a different distance. Then I'm also going to select our second direction, And you'll notice this time, once again, we don't have the right distance, so I'll reset that to 40. Now say that we had more of them, we could go up and count. And say that we wanted to skip some, I can click on instances to skip and say that it needs to skip that corner. Or maybe it needs to skip that one. But we're not going to truly utilize that, so we're just going to put it back to this. So here it's going to copy all of our components to each corner and put all of that under the local pattern. It also creates a small grouping of all of our hardware for us, and you'll notice the little lightning bolt next to it. That means that it's a smart fastener, so it's going to try to update for us. If something in the model changes that it's associated to, it'll actually update. Like say that we realize that these bolts are not thick enough, and we decided to change this hole from 3/8 to a 1/2 inch bolt, we could go back and change the original hole wizard hole from 3/8 to 1/2 inch. Then when we come back to the assembly, it'll update, and all of this hardware, as well as the hole transferring with the hole series, will update to a 1/2 inch bolt instead of a 3-inch bolt, as well as 1/2 inch holes. So there we were able to just, in the context of our assembly, create and fully design what our part needs to be based on referencing other components in the assembly. So it's not just that you're doing a little parlor trick, but you can actually design all your parts in the assembly. So that's all that I've got for this example. I've got one more example for y'all that I'll pull up here. We're going to be working with a spring, and this one is going to demonstrate if we have dynamic things that we want to be updating in the model. I've got these end plates that I want to put a spring between. Maybe it's the suspension on a vehicle that needs to go up and down of compressing and elongating the spring. I'd prefer for the spring to change its length for me. Instead of having a bunch of different configurations of our part, we can have it freely updating to update to the most appropriate setup. So I'm going to show y'all what I'm saying. So here I've got a distance mate between these two end caps. If I change it, let's say we want to put it at 10 inches, the spring stays in its original shape. And this is what you would expect from any normal component in assembly that you just pulled in. So here I'm going to put it back to its original, but now I'm going to put a new spring right over here. And just like last time, we're going to go under the assembly tab, do a new part. It's going to ask us what plane we want to work on. We're going to put the plane on the right plane of the assembly. And we're going to go to our appropriate view. The first sketch that I'm going to do is going to be the center line of our spring. And I'm just going to go from the top to the bottom of the opposite sides of the plates. And I'll show y'all why in a second. I'm going to hit that I'm done with this sketch. Then I'm going to create an additional sketch, also on the right plane of the assembly. And this time, we're going to put the circle, which is the cross section of our spring. I'm just going to throw a circle here and we can define it as we go. Here I'm going to put a few points just so that it's a little easier to mate it. So first off, our circle is going to be a 1-inch diameter, and this point is going to be on the top edge, and this point is going to be on the far edge. There we're going to grab the coincident. So now we've got everything defined. We're okay, so I'm going to hit OK. And the way that we're going to make this is we're going to use an advanced sweep technique that's going to sweep this circle around this center line a certain number of revolutions. And I'll show you that now. So under the Features tab, we're going to grab a sweep. I'm going to first select our center line, and by grabbing that center line, it's going to open up the options for me, and I'm going to tell it that I want to do a profile twist, and in this particular case we're going to do a twist value. I'm going to set our value to revolutions. I'm just going to say that's going to twist 4 times along, it's going to do 4 full revolutions along the length of that center line. Now finally I'll grab our cross section, which is this little sucker, and there you see it is twisting this profile along around the outside of this center line as it goes up the length, and I can change it. Let's say it wants to do 6 revolutions, or maybe it's only 3. We'll leave it at 4, and you can change it if you want to work in degrees, or if you're a mathematician you might work in radians, or maybe you need to do other things of not a specific twist but directionality to it. You also don't have to do a straight line. If this spring needs to curve, this center line could be a spline, or maybe it's just a arc, but that's just the simpleness of how we're creating that geometry. So the strong part about it is, now that I'm created my spring, I'm going to hit that I'm done editing, and here I can now change this distance mate between the two, and it'll update. So right now it's at 6, let's move it up to 10. And you'll notice that the spring geometry updates to match that it's always at that same position relative to the two parts, because the center line is being stretched. Here again, maybe it needs to go down to 4 inches. It'll compress it or extend it however we need. So we'll go to 8, and here I'll show you the one last thing that I wanted to show y'all with this spring was, you'll see that it currently goes through the model. Now this one I've got trimmed to that surface, and the way that I'm going to do it is I'm going to go back in and edit this part, and you can always go back to editing your parts in assemblies just by clicking on them, and this 4th option is edit part. So once again I'm editing the part, and you'll notice that it's denoted a little differently in the feature tree, and we have this exit edits part button up there. So the way I'm going to do this, I'm going to use some surface tab techniques. I'm going to grab a reference plane and just put a reference plane on that surface, putting it coincident, and an additional one on the top surface. Now what I'm going to do is I'm going to actually use these 2 surfaces to cut the spring. So I've got this surface selected, and I'm going to do cut with surface, and it's going to cut off that top bit. And the same with the bottom one, I'm going to select that surface and do cut with surface. And here now we see that it has been trimmed. I'll even open it up independently, and you can see that the very top of the spring has just been trimmed off. And once again, just to demonstrate the power of setting it up like this with references to the assembly, is that our part is going to dynamically update to keep its references happy. And what that means is we can have the part is going to change itself to keep the way that it needs to be. So here we can move it down to 6, and we're happy. Alright everybody, well that is all of my demonstration. Thank you for joining us today for our short demonstration on SOLIDWORKS top-down assembly modeling techniques.